In previous video, I taught you about increasing function, strictly increasing function, decreasing function, strictly decreasing function. And now, by using derivatives, we can decide whether function is increasing or strictly increasing, decreasing or strictly decreasing. For that, we are revising all these things. Let f be continuous function. Let f be any continuous function on closed interval ab, and f is differentiable also on open interval ab. Continuous differentiable. Then f is said to be increasing in closed interval ab. F is increasing in closed interval ab if f dash x is greater than 0 for each x belongs to AB. Second, f is decreasing in closed interval AB if f dash x less than 0 for each x belongs to AB. If f dash x is less than 0, then it is decreasing. And f is strictly increasing in open interval AB. Function is strictly decreasing or increasing in open interval AB if f dash x greater than 0 for each x belongs to AB. Strictly decreasing in open interval AB if f dash x less than 0 for each x belongs to AB. And f is constant function in AB if f dash x is 0. If f dash x is 0, then we can say f is constant function. So now, to decide whether function is increasing or decreasing, we have to find values of x for which f dash x is greater than 0 or less than 0. So first of all, you should know how we can find values for which function is increasing or decreasing. To decide increasing or decreasing, we should know it should be greater than 0 or less than 0. If we have fx in the form of x minus 1 upon x minus 2 upon x minus 3, like this, any function is given, and we want to know in which interval this function is greater than 0, in which interval this function is less than 0. To decide this, we use number line. This is also called baby curve method. In this, we put value of x minus 1 0. We will find all the values of x for which these factors are 0. Linear factors are 0, whether in numerator or in denominator. So x minus 1, x minus 2, x minus 3. And these factors should be in standard form. X is equals to 1, this will give you x equal to 2, and this will give you x equal to 3. So you put number 1, 2, 3 on this line. Here you write plus, minus, plus, minus. If here first term is positive, here we have positive sign, we will start from rightmost for this plus sign. If there we have negative sign, we will start from negative sign. And plus sign indicate in this interval this function is greater than 0. Positive means greater than 0. In this interval this function is less than 0. In this interval this function is greater than 0. So if you want to find out when f dash x is greater than 0, f dash x is greater than 0 in the interval of 1 to 2 and 3 to infinity. So we can say if x is belongs to 1 to union 3 to infinity, in this interval this fx is is greater than 0. If fx is greater than 0, we can say these are the interval. Same way, if you want to find out when it is decreasing, the interval, negative intervals are these two. To avoid the confusion, we can put here f dash x, f dash x, f dash x. If x belongs to minus infinity to 1 union 2 to 3, if the value of x belongs to minus infinity to 1 union 2 to 3, then f dash x is less than 0, or we can say in this interval this function is decreasing or strictly decreasing. If we have open interval, it means strictly decreasing. So function is given. First of all, we find f dash x, and from f dash x we will find values of point on number line. Then we decide the intervals. See one more example. If f dash x is equals to 3 minus x into x plus 5, f dash x is this one. Then first of all we write on in standard form. Standard form, x must come first, x minus 3 and x plus 5. And now we use number line. From this we will get xl to 3 and xl to minus 5. 3 and minus 5 this side, 3 is this side. But before these two brackets, minus sign is there. So we have to start minus sign plus minus. Here we have minus infinity, here we have infinity. It means if x belongs to minus infinity to minus 5 union 3 to infinity, f dash x is less than 0. F dash x less than 0, this function is strictly decreasing. In this interval, f dash will come less than 0. F is strictly decreasing. If x belongs to 5 minus 5 to 3, f dash x is greater than 0, and we can say f is strictly increasing. So by using f dash x and number line, we will decide in which interval this function is increasing or in which interval this function is strictly decreasing. If we have f dash x is equals to x minus 1 raised to 2 x minus 3 x plus 4. X minus 1 raised to 2 x minus 3 and x plus 4. Then on number line we will mark the point minus 4. From this is minus 4, this is 1 and this is 3. जिस फैक्टर के ऊपर इवन पावर आ रही हो वो फैक्टर हमारे लिए हमेशा पॉजिटिव रहेगा, तो उसकी वजह से नंबर 9 पर साइन चेंज नहीं होगी, बट इस पर f डैश x 0 होगा। अगर हम कहें f डैश x 0 कब कब होगा, f डैश x 0 होगा xl to 1 पर, 3 पर और -4 पर इन पर इस 1 पॉइंट को हम काउंट नहीं करेंगे। इस 1 पॉइंट को नंबर 9 पर हम ऐसे लगा सकते हैं। इसकी वजह से नंबर 9 पर साइन चेंज नहीं होंगे। अब साइन कैसे आएंगे, प्लस दिस विल होल रिमेन माइनस एंड दिस विल रिमेन प्लेस, प्लस माइनस प्लस, बिफोर दिस इज माइनस साइन और इसके बाद ही माइनस, यानी कि पूरे में माइनस ही रहेगा। इस 1 की वजह से साइन चेंज नहीं होगा, क्योंकि दिस फंक्शन बिफोर x अगर 1 से छोटा है तब भी पॉजिटिव रहेगा और x 1 से बड़ा है तब भी क्या रहेगा, ये पॉजिटिव रहेगा। तो इसके लिए क्या लिखते हैं हम, इफ x बिलोंग्स टू -4 to 1 यूनियन 1 to 3 -4 to 1 1 to 3 f dash x will remain negative। इस पूरे इंटरवल में नेगेटिव है, पर 1 पर 0 के इक्वल है, f dash x 0 है, इसलिए 1 को इसमें इंटरवल में से बाहर कर देंगे हम। और लिख सकते हैं इसको हम ऐसे, -4 to 3 except 1, same meaning, both have same meaning। f dash x less than 0, f is strictly decreasing। if x belongs to -infinity to -4 union 3 to infinity, f dash x is positive, it means f is strictly increasing। So in this way, by taking different values of f dash x, you can see how we can decide whether function is increasing or decreasing, in which interval it is increasing or decreasing. Let us see some questions from your book. Exercise 6.2. Question number 1. fx is equals to 3x plus 17. fx is equal to 3x plus 17. If we find f dash x, you will see we will get only 3, and 3 is always positive. f dash x is greater than 0 for all real numbers. It is remain always 0 for all. This implies f is strictly increasing on R. It remains always positive, so therefore f is strictly increasing on R because f dash x is 3 and 3 remain always positive. Next question. Question number 3. Fx is equals to sin x f dash x is equals to cos x. Part first, if x belongs to 0 to pi by 2, if x belongs to 0 to pi by 2, cos x is greater than 0 because the first quadrant cos x is greater than 0. This implies f dash x is greater than 0. If f dash x is greater than 0, f is strictly increasing. In the interval 0 to pi by 2. In second part B, x belongs to pi by 2 to pi. If x belongs to pi by 2 to pi, cos x is less than 0 because in second quadrant cos is negative. So therefore cos x less than 0 or cos x less than 0 so f dash x be less than 0. We can say f is strictly decreasing. In interval pi by 2 to pi. In part C, interval is changed. Interval we have 0 to pi. C part, x belongs to 0 to pi. In the interval 0 to pi, we know that cos x is greater than 0 for x belongs to 0 to pi by 2, or f dash x is greater than 0 for x belongs to 0 to pi by 2, and cos x is less than 0 for x belongs to pi by 2 to pi. Mean f dash x is less than 0 for x belongs to pi by 2 to pi. So sometimes cos f dash x greater than 0 in half interval. In half interval it is less than 0. So this function is neither increasing nor decreasing, because in first interval it is increasing, Second interval it is decreasing, but as a whole interval, if you see, then 0 to pi, this function is neither increasing nor decreasing. Neither increasing nor decreasing in the interval 0 to pi. Next question, question number 4. Fx is two x square minus 3x. Fx equal to 2x square minus 3x. We have to find interval in which function is strictly increasing or strictly decreasing. So first of all, we will find f dash x 4x minus 3. Then f dash x is equals to 0, x equal to 3 by 4. We can put on number line 3 by 4 plus minus. This implies if x belongs to minus infinity to 3 by 4, f dash x is less than 0, f is strictly decreasing. Here we have minus infinity, here we have plus infinity. If x belongs to 3 by 4 to infinity, f dash x is positive, f dash x greater than 0. This implies f is strictly increasing So in this way you can decide whether function is strictly increasing or decreasing. So tomorrow we will see some new questions. Till then, goodbye.